So welcome to all the attendees and certainly to the panelists here today. This is the first of several sessions this week that RunSafe's hosting as part of CyberWeek. We call it the RunSafe Security Bash. The first 5 events that we're hosting this week are of significant interest for a number of people in the cybersecurity space. Those include the 5G Security Bash today, the Cloud Workload Security Bash, and 2 DevSecOps events, and then a Software Supply Chain Security Bash on Friday. If you haven't registered for those events, please feel free to sign up for each of those individually. Also, RunSafe has organized a trivia tournament challenge that is benefiting the Cyber Statecraft Initiative. That's a part of the Atlantic Council. That event's tomorrow evening, and the winner of that event will be dubbed the smartest cyber company in the world. We've got dozens of companies competing and vying for that prize and have submitted donations that go towards a scholarship program for future cyber leaders as part of the Cyber Statecraft Initiative. So we look forward to that. As for today, we have just a couple housekeeping items. Attendees will be able to ask questions through the Zoom Q&A capability. Panelists do have audio and video capability, but attendees will only be able to ask questions by voice at the end should they want to raise their hand using the Zoom hand raise feature. But during the sessions, if you want to submit a question through the Q&A, whoops, sorry about that, then you can certainly do that using the Zoom Q&A feature. There is not a chat feature for attendees, but there is a Zoom Q&A feature. I am the moderator. I'm Joe Saunders from RunSafe Security. I'll do introductions in a minute, but we have a couple deputy moderators, if you will, that will be monitoring those Q&A sessions or questions as they come in. And for those that are timely and relevant for the current topics, we'll pose those. Others will be asked and saved for the end. And if you're following us and using social media, you can use either please tag RunSafe Security or CyberWeek as part of this session as you post that out. For those that aren't familiar with RunSafe Security, our goal is to immunize your software without slowing developers down across embedded systems, open source software, and certainly cloud workloads. We make that very simple to do, and 5G is a very important event for us to think about because we're looking at embedded software across the infrastructure that needs to be protected, as well as open source software that is used across all domains. And from a RunSafe perspective, we make it very easy to immunize your software, regardless of those domains and use cases that you have. As for today, we've got a distinguished panel. We are very delighted to have all 4 members participating. Certainly, Dr. Lisa Porter, who's co-founder of LogIQ, but former Deputy Undersecretary of Defense for Research and Engineering. And has a very distinguished career. And so we're very grateful, Dr. Porter, for your participation, as we are grateful for Randy Clark's contributions today. And he'll be sharing information about the National Spectrum Consortium, of which he is vice chair. But we also have Julie Holdren, who is Chief Product Officer of the public company VERB Technology, and has a high interest in 5G capacity going forward and all the capabilities. And so we'll be delighted to hear from Julie as well. And to kick it off, we've asked Gilman Louie, who is a partner at Alsop Louie Partners, to kick it off with a few comments about 5G. And as we go through this, we'll have Gilman kick it off with what we call, kind of what are the key stats? Is this a threat or an opportunity? And then we'll turn it over to Dr. Porter and Randy and Julie for some directed questions and some moderated questions. And then we'll save some time at the end for general purpose Q&A from the audience. So with that said, I'm going to shift gears slightly and offer the floor to Gilman. And Gilman, I've got your slides here. I know, Gilman, you have about 10 minutes worth of content, roughly. So I'll turn it over to you, Gilman, to kick us off.
Well, Joe, thank you for having me, and thanks to all the fellow panelists. I know everybody's busy, but this is an important subject. Let me first start off by saying my comments are solely my comments. They don't represent the AI Commission, which I serve on, or the Defense Innovation Board, which I advise. These are my own personal comments, but what I wanted to do was frame the 5G opportunity as well as the potential risks and the competitive set that's out there. Next slide. So why does it matter who wins 5G? You know, there's a lot of conversations about, you know, us versus China versus why 5G is important or may not be important in the rest of the world. Well, if you look back at 4G LTE, the US led the way as the first large nation to embrace 4G LTE and rolled it out ahead of the rest of the world. Thanks to companies like Verizon and AT&T, the telcos and the US infrastructure, we were able to seize the advantage, and that built the infrastructure for companies, the app companies, the cell phone manufacturer companies to build trillions of dollars of value by dominating the 4G LTE market. Fast forward to 5G. The estimates, you know, and there are estimates, but by 2035, that whoever wins 5G, the 5G market represents about $3.6 trillion by 2035 and creates 22.3 million jobs. And the issue for us in this kind of race to 5G isn't about individual companies, right? It is not to Verizon's or AT&T's shareholders' interest necessarily to know what's happening in China. But from a macro view, from an economic view and a global influence view, and given the importance of the potential of 5G as being the information infrastructure of the future, it becomes very critical that whoever uses that global network can trust that global network. Next slide, please. So the big difference between 5G and maybe 3G and 4G LTE is clearly heading in this direction. This is not just about passing information about people to people, you know, whether or not somebody's going to steal your credit card information or not, but because the networks, particularly the 5G networks, are designed to be high speed and low latency, are going to be the framework in which things talk to things, which means if somebody corrupts the network, if we can't trust the network to deliver the necessary information in time to the device who needs it, physically bad things will happen. It's more than just losing, you know, the credit card information. It's whether or not your car is going to operate properly, or whether an important switch that's controlling a particular critical part of your infrastructure is going to be flipped in time. So stakes are very, very high to get the 5G security model right, and for us to understand the vulnerabilities of the network and what we can do to avoid those vulnerabilities. Next slide, please. So I just want to point out kind of where we stand in 5G. There's a lot of talk about 5G, right? I mean, you know, we hear commercials about the 5G in the US is changing the world. We got 5GE, we got, you know, 5G low band and 5G millimeter wave. Well, what does all that mean? Well, if you kind of break up 5G across three major sections of the spectrum, you have the low band. The advantage of low band is it goes through everywhere and it goes a long ways, right? It's not particularly fast, but it's sort of like the mail, you know, it gets there and you can count on it getting there. High band millimeter wave is a very high speed part of the spectrum. We can put lots of information down that part of the spectrum because it's really, really, really fast, right? And it, on a performance basis in terms of just speed, it crushes low band and mid band. The challenge with high band is it doesn't go very far and it doesn't penetrate very deeply, right? Through walls, through windows. If you're moving around a lot, that amount of coverage is limited. So you need many base stations to cover. You need internal base stations, outside base station. Now, the Goldilocks band, as some would call it, is the mid band, right? Somewhere between 3G and 3 gigahertz and 6 gigahertz. And I'm going to take a little bit of the sliver to kind of let you understand where the world is heading. US rolled out low band and is high band and is working now on mid band, right? The CBRS, the C band, allocation auction is about that. The recent discussions about the Department of Defense sharing or releasing spectrum, it's to allow us to operate in the mid band. Now, the reason why we have a challenge here is mid band is also used by the military and the Department of Defense. And there's lots of things that are happening in band around radar and military use. So we do not have the freedom of a country, say, like China, which can just roll out in the mid band. The Europeans are also planning to roll out in the mid band, and Japan is already rolling out in the mid band. So if you take a look at the mid band spectrum, let's go to the next slide, please. Now, one of my portfolio companies, Aurora Insights, has a little satellite that kind of flies around the planet gathering RF signals. And this is a recent picture of the global 3.5 gigahertz usage. You can see Asia is just lit up, right? They are rolling out. To give you an idea, China just announced that they've, in this year alone, have installed 600,000 base stations, 5G base stations. To give you a matter of perspective, the US total base stations, not just 5G, all of them in aggregate is about 500,000, and they did it in a year. You can see hotspots in the Middle East. Europe is beginning to roll out, even Cuba is rolling out. We're waiting to kind of clear up that space. Our companies desperately need that mid-band space. Our telcos, our internet companies all want that, and we need to get into that space if we want to be competitive with the rest of the world. Next slide, please. If you just take a look at China, same satellite flying over, take a look at the bands, 3.4 gigahertz to 3.415 gigahertz. And Q2, you can see light usage, and within a quarter, take a look at what's going on in terms of amount of power that's being emitted from China. And that's consistent with all of those base stations being turned on. Now, what's interesting, next slide, please, is while 600,000 sounds like a lot, China estimates that it'll need somewhere between 5 million and 10 million base stations to fully serve all of China. Well, what does that mean? It means if I'm a national champion and my country chooses me to be the supplier of those 5 to 10 million base stations, I'm going to have a huge advantage over the rest of the world. And we can always see, in spite of us pushing hard, us being the United States, about warning of potential risk of using Huawei equipment in your 5G network, and many countries moving away from Huawei, if you take a look at 2019 and 2020, Huawei was still able to grow and now surpasses Ericsson in the number of global 5G base stations in terms of market share. And our prediction is that will continue to grow, driven not only on the Chinese internal acquisition of those base stations, but Huawei producing not just low cost, but very high quality base stations. They have awesome technology and capabilities in their base station equipment that they supply the rest of the world with. Next slide, please. So why do we worry about that, right? What's the difference? My iPhone is made in, physically assembled in China. So what if our base stations are made in China? Well, there are two parts of the equation I want to go over here. There are two fundamental strategies China has announced to the rest of the world and internally. The first one is made in China 2025. China wants to make sure that it is a world leader in 5G. Why? Because they see 5G along with AI, along with quantum sciences and other areas of technology critical for their economic growth and to lead the world in what they would call the fourth industrial revolution. So the other part of Made in China 2025 is they do not want to be dependent on any Western technology post 2025. They want to be, as we want to be energy independent, they want to be technology independent. The second part of this, which is a bigger concern, is they have a policy of civil military fusion. Fundamentally, it means commercial companies have a duty to serve their country first, beyond their commercial needs. So unlike the West and the United States, where the government cannot compel you to sell or change your product to meet military needs or national security needs, China has that as a primacy policy. Next slide. So let me give you a quote from the European Agency for Cybersecurity. The greatest threat to 5G networks, therefore, comes from other countries outside the EU. They may not only have the motivation, but also the possibility to attack 5G networks. These attacks could be very complex and have a major impact on the public and thus on traffic. The report also considers the possible actors as dangerous, such as insiders of a telecommunication providers or their service providers and organized crime. This shows that attacks under new standards will be costly and massive. So clearly the EU is concerned about this as the US. We're not the only ones that are worried about the security of our 5G infrastructure. Next slide, please. So here's what our US State Department just recently published. We should be concerned about all parts of the 5G network. No part of a 5G network should have parts or software coming from a vendor that could be under the control of an authoritative government. So in a way, this is kind of our version of Made in Trusted Country 2025, right? It's the other side of that coin. Next slide, please. So let's talk about some of the risks. Many of us who travel around the world carry, what we call burner phones or burner computers. Why? Because our IT departments warn us that if we take a phone or a digital piece of equipment overseas, you don't know what's going to land on your machine or on your phone. You're not in control of the networks. You don't know what the telco on the other side of the line is doing. You don't know what the apps are doing, right? One security analyst said that within an hour of landing in China, there will be malware on your mobile device. Now, that's probably an exaggeration, but the concern is real. Next slide. And by the way, you got to understand what we call spyware, the embedded technologies that track people is acceptable in some cultures as one of security and safety, whereas our primacy is around privacy, right, and control and independence. They do not share necessarily the same sorts of cultural ordering of priorities that we do. There are clear supply chain risks, and whoever controls the equipment will control the networks. So the integral part of a national security strategy is to encourage innovation. And the reason why this is really important is even if you can secure the software, you might not trust the chips, right? There's a thing we call chipping, where you find extra circuits on your chips. There's been some cases, at least reported cases of this happening, of additional circuitry there. Chipsets are so complex and so dense. If you're down at a 45 nanometers or even 7 nanometers, right, your ability to detect any changes of those chips and modification is very difficult if you don't control the supply chain. Next slide, please. Another vulnerability is the fact that most space stations are serviced by the OEMs. And there are very few US OEMs. So you might believe that the software running on the base station or the hardware is secure. You might test it rigorously. In fact, companies like Huawei have said, test my hardware, it's totally secure, right? Just pound on it all you want. But once it goes out into the field, right, who services it is just as important, who has access to that, because they could easily change or update or upload a new piece of software that may have vulnerabilities, maybe without any knowledge. Nevertheless, it only takes one vulnerability in the network to corrupt the network. Next slide, please. The fact that 5G networks will continue to interoperate with legacy networks means that these networks will continue to be vulnerable to attacks such as spoofing, fraud, user impersonation, and denial of service. This comes from IEEE, right? Because 5G networks have to work with older networks, right? So the vulnerabilities that are on 3G networks and 4G networks and LTE networks do not go away with 5G, right? So this is an ongoing challenge. American companies, American carriers take this very seriously, but we're playing in some case against potential nation state actors. And it is very difficult to defend against a determined adversary in cyberspace, particularly if they have national means. Next slide. So this is in full disclosure, I was one of the co-authors of this report, so I get the quote from myself. So take it for what it's worth. But we made these 3 recommendations, the DIB, to the Department of Defense. The first recommendation about 5G networks is we need to prepare to operate in a post-Western wireless ecosystem. That means, well, we might ban Huawei in the US. There's no guarantee if your traffic is going internationally that you can trust those networks in which it travels. And you should assume that all network infrastructure will become vulnerable to cyber attack from both an encryption and resiliency standpoint. So if you're just trusting encryption, we're telling you that you can't totally trust encryption. And you have to adopt the zero trust network model. Next slide. So I want to close with the following. If the world is going down 5G and the US can't catch the rest of the world and influence the rest of the world to take the same measures as the US is taking around security around 5G, and overseas international actors get to control not just the network, but the apps, because their apps are used to running on faster networks than ours, that their apps can be everywhere and ubiquitous, whereas ours can't, if we can't figure out how to share in the 5G mid-band space. Whereas our apps are very good at standing underneath a millimeter wave cell tower or your millimeter wave 5G at home antenna to get great YouTube. But everywhere else in the world, their users are experiencing the full 5G experience. Where does that leave the US, and how vulnerable are we really? So with that, Joe, I'll turn it back to you.
Well, thank you very much, Gilman. That was both stimulating for our discussion here this afternoon, and also very informative. So thank you for the comprehensive overview, and that perspective is super helpful. And I think that gives our audience a tremendous foundation, and it does set the stage for our discussion here with our distinguished panelists. So thank you very much, Gilman, and thank you for all that you do.
Thank you very much, Joe.
Okay, we're going to shift gears, and we have a chance now, based on Gilman's setup there. There's certainly some topics in there that I think will promote lively discussion among our panelists. But with that setup, I do want to shift gears a little bit and ask Dr. Lisa Porter to offer some comments based on her experience and introduce herself a little bit. But naturally, as I mentioned up front, she is now with LogIQ doing consulting, but has most recently within the Department of Defense served as the Deputy Undersecretary of Defense for Research and Engineering. So a lot of the topics here, she's got a tremendous background in. She's got a distinguished career, a PhD from Stanford, and actually served as the first director of IARPA for us. So Dr. Porter, welcome. And I'd like to ask you the first question, then I'll introduce the other panelists. But it'd be great if you could offer comments on, I know you're no longer with the US government, so you can't speak on behalf, and this is not any formal position, but it'd be fantastic if you could offer an update on what is the DoD's 5G strategy as you understood it, and could you, provide an introduction of that today?
Sure, absolutely. So yes, I'm no longer there, but I was certainly had a big role in all of that, and so I'm happy to speak to it. The actual official DoD strategy was published in May, but in fact, that was really kind of a written confirmation of a strategy that was in play since early 2019. And there's three major thrusts that you're going to see in that document, and you're going to see the DoD, I think, continue to execute on. And so I'll just very briefly touch on those. The first is the DoD's recognition that it needs to accelerate adoption of 5G. So there's a realization from the DoD early on that they don't want to be caught flat-footed in this revolution. And with that recognition was the parallel recognition that they needed to be very closely partnered with the private sector. And it's important to keep in mind that the DoD historically has some challenges when it partners with the private sector outside of its comfort zone, and that comfort zone is usually the traditional defense industrial base. Whereas a lot of the intellectual capital, frankly, in this domain is outside of that traditional defense industrial base, and it spans a lot of the companies that you've referenced, and in fact, that are members of the National Spectrum Consortium. So it required a lot of humility for the department to very early on recognize, look, this isn't the building of the next generation fighter aircraft or aircraft carrier. This is a technology that's going to be driven largely by the commercial sector. The DoD is not going to be the prime customer. It may not even be a critical customer. It will certainly be a customer, but the DoD needs to learn how to really partner with the private sector to understand how it can take advantage of 5G and address the vulnerabilities that are inherent in what's coming, as Gilman was alluding to. And so when I was there, I was loath to use the term public-private partnership. I think that's one of those vacuous terms that people throw around and really doesn't mean anything. But what we did was we said, look, we've really got to understand what we can bring to the table with all humility to an industry that's frankly running as fast as it can already, with or without us. So what can we bring to the table that offers industry an opportunity to say, yeah, we want to work with you, DoD, because we see value in that. And that's how we came up with those large scale experiments that the National Spectrum Consortium, of course, was a key participant in structuring all of that. And I know Randy's going to talk about that, so I don't want to steal his thunder, but that's one of the key themes of the DoD strategy. The second theme, and this is really important, and it's not orthogonal, it's related, but it's really important to highlight, is the notion of being able to operate through. Regardless, where and whenever the department deploys, it has to be able to operate, and it can't pick and choose where it goes, right? It can't say, oh, sorry, we can't go over there because, Huawei's there. That's not a viable position for the department to take. So the department recognizes that the reality of its world is a world in which it's going to be operating in environments where it's contested, where spectrum is contested, where the networks are contested and compromised, where the adversary is going to constantly try to get access to what you're doing, to compromise what you're doing, to spoof what you're doing, et cetera, et cetera. And you can't just say, well, we're going to construct, perfect things and then we can wish away that problem. So that's where zero trust architectures sort of became really important underpinning of what you'll see the department pursue. And unfortunately, that's another term that's become really popular and buzzwordy. And you hear it all the time, and people don't understand what it is. And one of the things that drives me crazy is I hear senior officials or people outside the government as well. They'll say things like, we're really going to do a zero trust architecture or a zero trust network. And then that's how we're going to have a trusted network, right? So, oh my God, then you don't understand what a zero trust means, right? So fundamentally, zero trust is about just accepting the reality that trust should not be your goal, right? Trust is actually a vulnerability that can be exploited. So you have to eliminate that as a goal. And, you know, I would have teased Gilman a little bit if he was still on the line here, because he was talking about people fall in that trap all the time. They talk about wanting to have trusted supply chains, trusted countries, trusted partners, trusted networks, blah, 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 because it sounds nice. It's like, if only we could have things that we could label as trusted and we could build our component parts out of everything that's trusted, we would solve the problem. The reality is, unfortunately, when we pursue that line of thinking, it actually opens us up to more vulnerabilities. And I remind people of this a lot. You know, we already learned this lesson in the early 2000s when that kind of thinking led to the perimeter defense models in networking security that many people, I'm sure, who are listening are very familiar with. And that was not a theoretical failure. That was a failure that resulted in things like Edward Snowden, which was a national security disaster. So I bring this up every chance I get because I think it's really important for people to understand that you really need to eliminate trust as your goal. Instead, you have to say, look, I need to understand that zero trust means the reality is I can't trust anything. So I need to architect solutions that address that reality. And that means, you know, risk management and risk assessment and management approaches, right? That are dynamic, that take into account all of the data that you can have access to. And also that allow you to architect things so that if a failure materializes, its effect is mitigated, not eliminated, because you can't eliminate risk, but mitigating when those risks materialize through architectures that are thoughtful about how you do that. So you hear about approaches like containerization, localization, and so forth. But it has to stem from that philosophy, and it can't be self-contradictory. So when you look at the DoD strategy, if you guys are curious, you'll actually see that nowhere in that document does it say that the DoD is pursuing a trusted network, right? And that was actually a big win to get that out of the building. We had to explain this to the policy folks, that we're not saying this means that you should embrace untrusted, you know, adversarial components. Clearly, you don't go out and buy a bunch of Huawei gear if you can avoid it. That would just be stupid. But the contrary to that is also stupid, to think that just because you don't have Huawei in your system, that you're good to go. And, you know, I had to remind a lot of folks, the Russians, for example, this is well known and out in the public, they have no problem exploiting networks and they don't build any of the hardware. So you don't have to be the builder in order to exploit it. And you don't have to, you know, necessarily say, I'm just going to eliminate all the known bad guys and now I'm going to have a perfect solution. So it took a while for the building to really understand that. It's a subtle and really important point. And if you read the strategy, you will see that it is captured in there. You're not going to see that consistency everywhere, but you will see that consistency, I think, from the DoD. And it's an important one. And it's, by the way, one that folks like Randy and others fully understand. So the private sector has really come to understand that. They've been driving zero trust and what it really means, as you guys know. And it's really important, I think, for us to speak up about that very openly. And the third point I would make very briefly, because I know we're over time here, the third main theme you'll see from the DoD is the notion that there is no finish line. So with all due respect to Gilman and everyone else that likes to characterize 5G as a race and that something that we have to win, I really don't know what that means because there is no finish line here. We're going to continue to see technology advance and we have to continue to innovate. And we have to continue to push ourselves to 6 and 7 and 8G or whatever it ends up being called as time evolves. And the reason I make a big deal about this is because historically in other technology domains, this country has convinced itself it has to win a race. It sets a timeline and it creates a short-sighted approach to technology advancement, which usually leads to export control and other policies that ultimately in the long run hurt us. And so, because once you get to the point where you've won, well, then what? I mean, time keeps going, right? And so all you've done is incentivized an environment where the rest of the world is going to work twice as hard to catch up with you. And now you've taken yourself out of the game. So we have to play the long game. And we have to recognize that innovating means pushing ourselves forward rather than being so fearful that we're trying to just hold everyone back. You can't get ahead if you're just holding everyone back, right? Or to use a good, I'm a Patriots fan, to use a good football analogy, you can't win just by playing good defense. right? So you got to get on the offense, and that means being willing to take the risk, continue to invest, continue to pursue those technologies. And now I'm hoping I'm setting it up for Randy, because the spirit of the collaboration with DoD and the private sector was, let's prototype at scale. Let's really get after this. Let's figure out what works. You'll notice there's no mention of DoD 5000 anything in the strategy. There's no obsession with programs of record. The whole point was, let's run fast, let's prototype, let's break what doesn't work and move on, and let's go with what does work and try to implement and deploy. And so with Randy, hopefully I've set up a little bit more for you to talk about the strategy and what you guys are doing there at the NSC.
Yeah, and thank you, Dr. Porter. It's great to know the DoD had your leadership in these areas, and your comments are much appreciated. And I think the framing of those 3 points in light of the 5G strategy, and in contrast to some of Gilman's points, are also greatly appreciated. So thank you very much. And we'll come back to you, obviously, and when we start to do some general questions for the panel. But I do want to turn it over to Randy. And Randy, you're one of the leaders of the National Spectrum Consortium. And it would be great if you could summarize what the National Spectrum Consortium is all about, so the audience knows that, and then some of the progress and some of the items that Dr. Porter was alluding to in terms of experimentation and the like. If you could kind of summarize those aspects as well to help frame that, and then we'll come back to Julie Holdren after that. So thank you, Randy.
Absolutely. So the National Spectrum Consortium is an OTA. It's an other transactional authority. It's one of 28 within the DoD. Our spectrum management firm is ATI. We were established about 4 or 5 years ago off of the AWS-3 auction, where the Department of Defense relinquished ownership of 1755 to 1850 in order to pair it with FCC spectrum and make it available to the commercial market. If those that follow spectrum remember that that was a record auction, I don't remember off the top of my head, but it was around $42 billion. Part of the proceeds from that auction went back to the Department of Defense in Spectrum Relocation Fund. And the intent of that fund was to prototype for the replacement of the legacy systems that operated in the band, and to innovate from a spectrum perspective. There are many within the United States that believe, as I do, that spectrum agility is one of our competitive advantages. And that ties in well with other comments made about software. I mean, one of our competitive advantages globally is in the software space as well. So we have to continue to invest in software solutions. We have to continue to invest in operating through contested and congested spectrum environments, as Dr. Lisa Porter pointed out. And the only way we're going to get there is to continue to invest in prototyping. Sal Vitri is the current elected chair of the National Spectrum Consortium, and he is famous for being quoted that prototyping makes good policy. And if you think about that, it is probably the truest, shortest quote in the spectrum community. And it goes beyond spectrum. Prototyping makes good policy on all facets of what the Department of Defense and our federal government should be doing. So much more energy needs to be focused around the S&T and the R&E work, so we get the policies right, because the policies are what are going to govern our behavior as a nation. So today, the National Spectrum Consortium is about 380 members. About 200 of those members are non-traditional. This is important because, as Dr. Lisa Porter pointed out, is that in order for us to concentrate on disruptive technologies, leap ahead technologies that focus around zero trust and dual use, we have to tap into the true creativity of this nation, and that is going to come from our non-traditionals, our academic partners, the Silicon Valleys, the Triangles, the Austin, Texas areas of this nation, so we can identify those leap ahead technologies, prototype them, and hopefully set reference architectures for how the Department of Defense and the federal government and the fourth industrial revolution base will consume 5G in a secure fashion. because 5G is so critical to the economic drivers of this nation and the world. It has to be secure because it is mission critical. One of the things that Gilman pointed out early was that 5G was different. You know, it's about application to application communication without human interface. Application to application communication without human interface. That's important because humans have a sense of when they're being hacked, right? In a true autonomous environment, our AI has to have those kind of characteristics and behaviors to understand that something is wrong. And at the speed at which automation is going to accelerate because the integration of AI and ML and cognitive learning engines, it'll happen so fast, faster than the human can perceive. So this is where zero trust is going to play a primary role in responsibility, in this environment. So implicit, there's no such thing as implicit trust, as Dr. Lisa Porta pointed out, right? We can't trust the user, we can't trust the assets, we can't trust the resources, however, we can trust at a certain level the process that we put in place. So zero trust really, in my mind, has two formations. One is a hardware-based environment, which is Juniper, Palo Alto, Cisco solutions sets, and they're valid for use cases. And then there's a software-based zero trust, which is protecting data in transit over untrusted hardware, over any IP modality in the world. And that's an important nuance because we do know that we can't trust hardware, right? There has been a compromise to the microelectronic supply chain. And we, in our short and midterm mitigation tactics, we have to employ some of these zero trust principles to provide the protection we need immediately as this ecosystem grows and the economy explodes. In tranche one, the National Spectrum Consortium was chosen to work on those experimentations. Happily, they were recently announced. We did smart warehouse in Albany and San Diego. We did a dynamic spectrum sharing experiment at Hill Air Force Base to characterize the behavior of a non-cooperative aerial radar with a ground-based system. Very important research, very difficult experiment. Hopefully that bears a lot of great truth that we learn through prototyping, right? And then of course, AR/VR at Joint Base Lewis McChord, which is dealing with how, sensor to shooter environments are going to operate, leveraging the dynamic ability of 5G protocols to go over different spectrum bands, but how we're going to enable that sensor to shooter environment with a hyper disconnected warrior. The second tranche is out, at least the first half of it is through the IWRP. They're more tactical in nature in my mind. To Lisa's point, she had indicated that it's more about the operation of through contested and congested environments. This is very important, and we have to have spectrum agility to do that. This will put a lot of research on the leveraging of software-defined radios, zero trust architectures, the use of perhaps quantum real number generators to create new digital certificates and new encryption keys for every software-based routing instance we create with virtualized VPNs. I'll close in saying that all of this work that we're doing today is truly a matter of national security. A strong economy is the best defense. Part of the role that the National Spectrum Consortium will continue to play is to be the center of the collaboration between industry and academia and the U.S. government. We are establishing working groups and not only spectrum coordination efforts with the NDIA, but also informing future requirements, standards requirements for the 3GPP. And a new idea is to federate labs across the federal, state, and academic level. So we start sharing resources and building a center of excellence or multiple centers of excellence that focus experimentation in certain areas, but the entire community learns from those best practices and that research, so we can iterate faster, so we can go from concept to production quicker. And that's what's going to stimulate the economy, and that's what's going to keep our country safe. So I'll turn it over to Julie. Thank you, Joseph.
Yeah, thank you, Randy, and thanks for all those comments. And I do agree, the economic implications are significant, and I'm also grateful for your leadership as part of the National Spectrum Consortium. RunSafe is a member, but your contributions are significant and much appreciated. And so with that, though, you brought up kind of the application to application and the interfaces. And fortunately, we have one of the best chief product officers I know, Julie Holdren, who is going to give us, an angle on what are some of the implications from the private sector view, and what are some of the top use cases going forward, and what do you make of, those interfaces required that are out there, Julie? So happy to turn it over for you for a few comments. And just before I do, though, if I could just remind the audience, if you have some questions that you want to ask via Q&A, please use the Zoom feature to pose your questions. We'll try to get to those. But Julie, please take it from here with top use cases and private sector implications.
Well, thank you. I am very excited to be here. The comments I'm speaking on are my own. I am the Chief Product Officer of VERB Technology, which is an interactive e-commerce technology company. I am very excited to hear everything that Randy and Dr. Porter had to say, because it really feeds into what we're seeing in the market. Right now, due to 5G and the Industrial Revolution and the pandemic, what we're seeing is a great consumer demand for many use cases in telehealth, e-commerce, manufacturing, and IoT. Globally, the largest shopping mall in the world right now online is in China, and that is definitely indicative of the consumer and enterprise appetite for these types of solutions that be riding on these networks. What's paramount right now is understanding the ecosystem and the exponential vectors of attack now within the 5G network that I was referencing before, and it's incumbent on the vendors that are building these solutions to make sure that everything is hardened as they deploy these solutions. There's going to be a lot of opportunity for new companies. The next Googles and Apples will emerge out of this industrial revolution, and it's continued to be fueled by the change in consumer behavior globally. We are also seeing on the consumer side the leapfrog of technology, where countries that were hampered and unable to keep up with the 4G LTE environment will go right into the 5G, 6G immediately and leapfrog into that technology. The world is more flat than it ever has been before. So the application to application interface and the architecture behind that interface will emerge exciting and technologies for both the consumer and enterprise space. Understanding those solutions and the use cases go anywhere from skateboarder videotaping themselves and being able to frictionlessly purchase the shoes that they're wearing or the skateboard that they're wearing. For multi-level marketing, that environment as well, you'll be able to have interactive video and real-time purchase while observing someone in a cooking show. You'll be able to purchase the ingredients, you'll be able to purchase the supplies, and the fulfillment centers that already exist today will be able to deliver that information for you without ever having to open up any third-party applications. So it's a huge opportunity for the consumer and enterprise space to be leveraging this infrastructure, but they need to be prudent about the security aspects.
Very good. Thank you, Julie. Greatly appreciate your comments, and look forward to a lot of that increased capacity that we will have, and with speed, connectivity, and reduced latency. A lot of those transactions that you talk about will be possible and feasible. So we do have some kind of questions that we would like to pose all panelist members, and we've talked about the ability whether we can trust the network. But we haven't really explored whether we will have a national 5G network now or ever, or will we always be federated or distributed? So I'm curious if someone can kind of round out the thinking there based on today's discussion and your own experiences.
I think I'll open up the conversation by saying, I turn your comment around about trusting the network. What about trusting the data as it traverses networks, right? This is a global economy and we operate globally. We'll never be able to trust every network. So we have to trust the data in transit over those networks. I think that is implicit to the software-based zero trust architectures that are being proposed. I don't know, Julie or Lisa, if you wanted to make a comment.
The data in transit, particularly with IoT and the e-commerce side, is first and foremost on the vendors that are providing the consumer and enterprise applications right now, and the vectors of attack. And to be honest with you, I find it daunting as to how we go about securing that throughout that system. And it's something that I think the investment community will also be looking at to see what the solutions are and how they're being brought to market. Absolutely.
And I'll just defer to my deputy moderators. If there's any Q&As from the crowd, please chime in, but I'll keep going. Okay, and will we ever see a national 5G network?
If I could start that one off too, and then I'll turn it over to Lisa. It's an antiquated idea, right? Building proprietary waveforms on proprietary spectrum for proprietary hardware for proprietary missions is old school. Yep. We cannot operate effectively and scale and be agile in that environment. So what 5G actually does is provide a protocol to operate over any frequency in a virtualized environment where the core is virtualized and the RAN is virtualized. Network slicing and beamforming gives us an opportunity to create private network architectures virtually and leverage the existing infrastructure that exists. So I'll stop there. I know Lisa's nodding her head, so Dr. Porter, please, ma'am.
So yes, Randy, I fully agree with you, and you said it very well, so I don't want to drag it out. I think there's a lot of confusion out there. People use that buzzword a lot too, and they don't really know what they're even saying. So I think, you know, as we're seeing the Open RAN community really take off, and that's no longer a theoretical discussion either. Rakuten and now Dish is really making that real. A lot of work to be done. You know, as Julie says, it's daunting when you think about all the technology challenges that we have to solve, but if you're an engineer, it's also really fun. And we have amazing brilliance in this country to solve these kinds of hard problems. We have to create the right environment to encourage that. And as Randy, as you were saying, that entails opening everything up, going the opposite direction, right? Open interfaces, allows for the open hardware, software, everything you were saying. And that's what we should all be pushing for.
Fantastic. And we did have one question come in from the audience that I'd like to direct, if I could, to Dr. Porter and Randy. So obviously the National Spectrum Consortium has launched the $600 million prototype experiments. Where do we see that developed technology going? Is that DoD only? Will that be US only? Will that be beyond? And what's the success of those programs? What's the kind of the expected outcomes, and how far will those experiments travel, if you will, beyond the DoD?
Randy, you might want to take that only because you're the one that's still authorized to speak on this, if you will, since I'm not actually in the DoD.
Roger that, ma'am. So the intent of Tranche 1 was, zero trust and dual use. Dual use it being extremely important because not only did we have to identify and look at increasing the operational efficiency of the Department of Defense's operations, we needed to learn how to increase the lethality of our warfighter. At the same time, the investment in those technologies had to have a commercial benefit so we could stimulate the U.S. industrial base or our economy to grow fast. As I said earlier, the best national defense is a growing and healthy economy. I'm not going to touch on the $600 million because there's some, debate as to what that actually is. However, I think that number is really talking about phase 1, phase 2, and phase 3 in out years. It was a single award, for tranche 1. So just to clear it up, I think they're talking about the life of the experimentation through the period of performance and the potential investment, but I don't think that money has been allocated. So I'm not going to talk any more about that. But this was the start, the beginning, and it created the beehive, right? The conversation opened up, the collaboration started. The real point is, how do we continue to collaborate openly in a rapid acquisition methodology with the government? Because we have to help our partners change and understand based on what's happening in the commercial markets. This is not something they're used to. So we have to keep it open. We have to keep it collaborative. We have to provide continuous feedback so they can continuously improve the process. And hopefully that answers the question.
Yeah, I think that's very clear. And thank you, Randy. Okay, so I'd like to close just on, a two-part question for each panelist. And we'll start with you, if we could, Julie. Just, kind of your outlook on whether short-term or long-term risks related to 5G, and then any other recommendations you have. And then if I could go to Randy after that, and then we'd like to wrap up with Dr. Porter, if we could.
I think on the consumer and enterprise side, the risk is diving into providing solutions that are 5G enabled without thoroughly vetting your ecosystem and your supply chain out, and being enthusiastic to solve the problem that's being driven by the enterprise and consumer demand. And I'm incredibly optimistic about this market. It's probably one of the most exciting times in my career, as the other panelists were saying. It's very interesting problems to be solving. So thank you.
Very good. Yep, thank you. And Randy, just a short-term, long-term view of risks and any recommendations you'd like to wrap with, and then same question for Dr. Porter afterwards.
So short-term risk is doing nothing. That's a risk. Doing it too slow, that's a risk. Doing the wrong thing, that's a risk, although you have to experiment and fail, but you got to fail fast. And I think that those are the important ones. The 8th layer of the network, which is the political layer, right? We cannot let rice bowls and the way we used to do business continue to affect the outcomes of these experiments, because then we're completely missing the original intent of the experimentation. Remember, prototyping makes good policy. Let's make some good policy. Lisa?
Yes, Dr. Porter, we'd love for you to end our session with your final thoughts and comments, and we greatly appreciate that as well, whether risks or recommendations.
Sure. So just to amplify Randy's point, I like to say it's velocity, not speed, that matters, right? You've got to move fast, but you got to be moving in the right direction, or else you just, could be a lot worse than not moving at all, actually. And we've seen that. So I think the collaborative spirit has to continue. The risk around people being fearful is a real challenge that we have to counter. So there's going to be failures, right? There's a lot we don't understand, and I think we have to be honest. So the tendency, as you know, is the marketers get out in front of the engineers and they talk about things already being solved. And we're seeing that already with the commercials out there. There's a lot left to be done, and we have to manage those expectations. Because the upside is so awesome, it's worth managing those expectations now, so that people don't become disillusioned and turn away from what's going to be a long-term investment play. We have to keep going. Whether it's 600 million, 800, whatever the number ends up being, we have to remember that Congress was a key player in all this, right? They were extraordinarily supportive of the DOD. I spent a lot of time myself on the Hill with both parties. It was bipartisan support. It was all committees, because they saw the value. So we have to continue to ask them to believe in that, right? And to get out in front of this short-term thinking that we tend to find ourselves in, Randy, which, as you know, can be anathema to the progress that I think we've been advocating for. So the long-term play, focus on that innovation. Don't be afraid to fail, as long as you learn from it and you keep going. Just keep going, right? That's what I would say.
Well, thank you to all of you. Thank you, Dr. Porter. Thank you, Randy. Thank you, Julie. We greatly appreciate all of your participation. Thank you to Gilman for his comments up front. And, this is one of 5 events this week. And I hope that the rest of them will be as, filled with expertise and thought-provoking ideas. I thought we covered a lot of territory in a comprehensive way, and greatly appreciate all the expertise that's here and all the contribution to 5G going forward. So if any audience members want to attend other events, you can register at runsafesecurity.com. Check out our blog page for that. And thank you again to the panelists for a wonderful discussion. Have a great day, everyone.